So when we're looking to find the intervals over which a function is increasing, decreasing, or where that function might remain constant, I think about it as going on a little roller coaster ride at the fair. Anybody go to the fair this weekend? No? Oh, yeah, okay. All right. All right. So Tyler's going for a ride, and he was the only one that went to the fair, so I'll put him in the car alone. There we go. All right. So here we go. He's going on the little roller coaster ride, and so we're going to take a ride down this function. So what does he do first? He goes up, 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 up.
Oh, he increases, he stays constant, then he decreases, then he increases.
Exactly. Okay. So that's what we're going to think about as we're doing our intervals of increase, decrease, and where the function remains constant. Okay. So when I'm describing what's happening, I'm describing how the y is changing. Does that make sense?
Yes.
So to describe how the y is changing, I have to use x values. Over what x intervals is the y changing and how is it changing? Okay? So what I've done down here is I've drawn a little x-axis. And this end of the x-axis is negative infinity, right? And this end over here would be positive infinity. And what I did was I looked to see where would any extrema occur on this graph. Well, it looks like I've got one right here at 0. And then there's a change over here at 2, and then another change occurs at 3. So on this interval, you guys told me just a minute ago that this was increasing. And then this, what did you call this? Constant. And then from 2 to 3, what happened? Decreasing, and then from increasing. So if we look at this, these intervals would tell us this function is increasing from negative infinity to 0, constant from 0 to 2, decreasing from 2 to 3, and then it's increasing again from 3 to infinity. And what do I use to show the union? Okay? So these are the intervals over which the function is increasing, decreasing, and where that function remains constant. So we're always going to use our x values when we're describing these intervals. Yes, Sarah?
Are we writing it like a coordinate instead of the brackets?
We're writing it using interval notation, which gives us the least value to the greatest value every time. So does it look like a coordinate? Yeah, it kind of does. But it's really the interval notation where I start off with the least value and I work my way up to the greatest value over that interval. Anyone else? All right. So this function did some crazy stuff. Most functions aren't that exciting. Like this function. I tried to make it an absolute value function. It looks like it might be off just a hair. But you don't have to know the name of the function at all. Right now, you just have to tell me over which intervals does this function increase, decrease, or remain constant. Does this function have a constant interval at all? No. There are no horizontal segments, are there? And that's the only place where it would remain constant. So right here at negative 2, it appears we have an absolute min on this graph. Yes, sir?
So on the first one, for increasing, for like when we put the point where it starts increasing and starts decreasing.
Well, you always start on the leftmost portion of your graph, which in this case is going to be this left arrow. So what happened when I started right here and I was proceeding from left to right on this graph? It's increasing. So we would say from this left arrow, which represents negative infinity, I went up until I got to an x value of 0. So that first, from this ray, is increasing from left to right. So and what you could do, guys, is just put your finger on this arrow. What do I have to do first? Go up. That's increasing. Then I go straight across, constant. Then I go down. Then I go back up. Okay, so if I put my finger over here on this arrow, what's going to happen first on this next graph? It's going to be decreasing. Yes, Jessica?
If like the arrow is going down on the right side, is it still positive infinity?
What we're thinking of is our x values. So we're going to always, if there's an arrow pointing left at all, we're always starting off with negative infinity. Because if the arrow points left forever, that's negative infinity for my x value. Whether it points up or down. See, this one pointed down, and that's negative infinity. This one points up, but I'm still starting off at negative infinity because I'm thinking about my x values. Yes, Rose?
So whenever you're notating the increasing and decreasing in the constant, you always use the x values?
Yes, we're always going to use our x values when we're giving our intervals of increase, decrease, or where the function would remain constant. Okay, so this one, if I start right here, I'm going down first. Well, it pointed left forever, so I'm going from negative infinity to negative 2 is decreasing. And then from 2 to infinity, what is it doing? Increasing. So, decreasing from negative infinity to negative 2, increasing from negative 2 to infinity. Yes?
Do you ever have to use the brackets or whatever, like to like the parentheses?
That is also a good question. It is accepted if you use the bracket on the number. I do not. Because when I think about this point right here, I think I'm decreasing until I get to this point. At this point, to me, in my brain, I go, a change is happening. I'm going from decreasing to increasing at this point. I've seen it used both ways in text, and I've been in meetings where teachers argued passionately that I should include it also. So if you include it here, I'm not going to count it off, but it makes sense in my brain that until this point it was decreasing, and this is where a change occurred. Alright, so here we have a parabola. You don't have to know that either. But if we looked at this from negative infinity to positive infinity, and we have one maximum value that we need to notate on here, and what is the x at this for this point? 2. So what is this function doing? So if I put my finger right over here, if I put my finger right there, and I started traveling this function, what am I doing?
Increasing.
I'm increasing. And then I would be decreasing. So it is increasing from negative infinity to 2 and decreasing from 2 to infinity. You try this last one.
What would you say? Those constant.
That first example we did was constant. So this one's got a constant interval. Where is it constant?
Yeah, I mean, like homework, if it had no constant, but it said the word constant would be like.
You just leave it blank.
Okay.
Your slash or.
Good job.
Got it. Got it. Okay, for increasing, did you get from negative infinity to negative 2?
Yep.
For decreasing, did you get from negative 2 to 1?
Yep.
Constant from 1 to 3? And then increasing again from 3 to infinity. Okay. What I'm going to do next is I'm going to put up an Are You Ready? So, you have a quiz tomorrow. Are you ready? Okay. So if you're watching the video, I'm going to end it here. You can check your answers. We're going to go over the answers to this right before your quiz tomorrow.